This lesson is on rate of change and slope. First, take a look at the rate of change. The definition of rate of change is change in dependent variable over change in independent variable. And when you look at a graph, usually we use the y-axis to represent the dependent variable and x to represent the independent variable. So rate of change can also be defined as the vertical change, which is the y-axis, over the horizontal change. Change in y, change in x. So let's look at one example to see how we can use a table or a graph to find the rate of change. Okay, so let's examine this table. This table has several points listed there. The point -4, -2, -2, -1, 0, 0, 2, 1, 4, 2. And we can use these points to graph this line. So this is -4, -2, right? X is -4 and -2. And then -2 and -1, 0, 0, 2, 1, 4, 2. So with these 5 points plotted on the coordinate plane, we can join them to form this line. So this graph and these points are representing the same relationship. Okay, so how do we find the rate of change? It's the change in dependent variable, which is the y change, over the x change. So in order to change, we have to start from somewhere and then end up somewhere else. So and then we can see the change. So let's say we examine the change from this point to this point. Okay, so this is where we begin. This is where we end. Okay, so the change is, first of all, I'll figure out the change in y. The change in y is the final destination of y, which is -1, and then subtract the original one. This is how we find a change, right? Subtract the original y, right, before the change, which is -1 minus -2, and then over the horizontal change, the change in x. So x has changed to -2 from -4. So it's -2 subtract -4. And that gives us -1 plus 2 over -2 plus 4. And that is 1 over 2. So that's the rate of change from this point to this point. Okay, let's look at the change between two more points. So let's say this time I want to look at the change from this point 0, 0 to this point 4, 2. Again, doing the same thing, I will take where I end up at, like this point, compared to the original point that I started with, which is this one. So you take the final to subtract the original, right? So let's look at the change in y, which is the numerator. So we're going to take 2 subtract 0 over the change in x, which is 4 subtract 0, which is 2 over 4, which is again 1 over 2. Interesting. Why don't we look at one more pair to see if we will get 1/2 again? So this time let's look at how about between this point here and this point here. Okay, so from -2, -1 to 2, 1. So this is where we end up at. This is where we began. So we'll take this final point to subtract this original point. So let's start with the y. Y is always the numerator, the y change. So it's 1 subtract -1 over 2 subtract -2. And that you have 1 plus 1 over 2 plus 2, which is 2 over 4, which is, oh, amazingly enough, again, we have 1/2. So do you notice that in this graph, which is a line, the rate of change is constant. And you shouldn't be too surprised about that because remember, this is also a proportional relationship. And in that, the ratio of y to the ratio of x is always constant. Let's look at another example. The following table shows the height of a ball after being tossed up. What are the rates of change in each time interval? So I have time in seconds. So at time equals to 0 second, the ball was still at the ground level, which is also 0, which is the height. And then after like half seconds, the height has reached 18 feet. And then as time increases, the height increases. But at this point, you see that when time is 2 seconds, actually there's a decrease in the height. The ball has begun to drop down now. So let's find the rate of change at each interval. Okay, so let's look at like 3 different intervals. So from 0, 0 to 0.518, again, is the change in y over the change in x. So the change in y, oh, which one is y, which one is x? All right, you may wonder. Remember, x is the independent variable, and we know that time is also independent variable. So time is the x-axis, and height is the y-axis. Okay, so let's find a change in y over a change in x from this point to that point. So we will take the second y, which is 18, minus the original one, which is 0, over the change in x, 0.5 minus 0, okay? And after some calculation, you get that is equal to 36. And then for the second interval, so we are looking at these 2 points. Again, we take the second y to subtract the first y. So I'm going to write it here. So it will be 31 minus 18 over the change in x, 1.5 minus 0.5. Let's see what we get here. So I have 13 over 1, which is 13. Oh, this time we get different rate of change. All right, let's look at the last one. The last one is 26 minus 31 over 2 minus 1.5, and that is, I have a negative number, which is negative 5 over 0.5, which is negative 10. Do you notice that in this example, actually we have different rate of change? It's very interesting. So let's take a look at the graph. So this is the graph that represents the 4 points listed in the table. We see that these 4 points here, actually they don't form a line. Well, when you have a line, the rate of change is constant. But if you have like rate of change between different intervals are different, like in this case, you know that they don't form a line. The points don't form a line. Okay, what is rate of change? Again, rate of change is the change of y. What does that mean? So in the first example, we looked at these 2 points. So from this point to that point, the y change. So we go from this y and then up there. Okay, you see y has gone up that much, the change in y. What about the change in x? The change in x is the horizontal change. We went from here to here, okay? And then we look for the ratio of the change of y. So we are taking this over that. All right, so that means if there's more in the change of y for just a little bit of change of x, you will expect that you get a big number, right? A big change of y on top of the fraction over a small number in the bottom, which is the denominator of the fraction. So you would expect the overall value is big. And if I have like big change in y and small change in x, what does that mean? That means this point goes from here, maybe to, like in this example, like goes there, okay? The y changes more than the x. It's kind of like steep. You see how steep that is if I join these 2 points? And then when I looked at the change between these 2 points, you can see if I join these 2 points, it's like less steep, right? So for big change in x, like from here to here, it's much more than between these 2 points. And then the y only goes up this little bit, right? That means the change in y, this one, this distance, over change in x, this distance, is smaller. And we can see that from the value between the first two intervals, the 2 points, the ratio is 36, rate of change is 36. And then for the second one is 13, so it's smaller because it's less steep than the other one. And then between these 2 points is interesting now because x still goes from here to here, right? The horizontal change. This point has the x value correspond to this point. So from this point to this point at this much. What about the y? The y actually goes down from top here to a little bit lower point. That means the y is a negative number. The change is a negative number, okay? So we have a negative rate of change. Now x still increases, but y decreases. So we have a negative over a positive, so the overall is still negative. And as I described that, you notice that I use the terms the steepness, right, between the 2 points, like the line joining the 2 points, which brings up the other thing that I want to talk about, which is slope. Okay, for a line, the slope, we use m to denote a slope, is also its rate of change between any 2 points. And I want to emphasize we're talking about a line, okay? Because in this past example we just saw, these 4 points, they don't form a line. That's why you see that the rate of change is different, right, between different intervals. But for a line in the previous slide, it's a line, and the rate of change is the same between any 2 points. So the rate of change is a constant, and the rate of change also is the slope, the steepness of the line. And so slope m is also defined as change in y over change in x, or y2 minus y1 over x2 minus x1, right? From the second point, we subtract the first point, okay? Because we go from first to second, so we take the second to subtract the first. All right, let's play a little bit more with slopes. I have 2 graphs shown here. One is a red line, the other one is a blue line, okay? You can instantly tell that the blue line is steeper than the red one. So let's try to figure out the slope of these 2 lines. I can use like m1 to represent the slope of the first one, which is the red line. And of course, I'm looking for the change in y over change in x. So let me just pick any 2 points, because remember, for a line, it's constant. So it doesn't matter which 2 points you choose. So let me choose, I always like to choose 0, 0, because when you subtract 0, you don't have to do anything at all. So let me choose 0, 0 as my point 1. And then my point 2, I'm going to choose this one, 2, 2. Okay, so for m1, which is y2, y2 is also 2, minus y1, which is 0, over x2, which happens to be 2 also, minus x1, which is also 0. Okay, and that is 2 over 2, which is 1. Right, so the slope for the red line is 1. What about the slope of the blue line? So let's call that slope 2, m2. All right, so again, I want to pick one of the points to be the origin, and the other one, I mean, you can pick any one. You can pick like a negative, in this quadrant, we have negative values of x and y, but I try to stick with the first quadrant because I like to deal with the positive numbers, don't you? Okay, so I'm going to pick this one, which is 1, 4, okay? So remember, I'm going to pick this one, 1, 4, and then use this 0, 0. Okay, so the slope is, I'm taking the second y, which is 4, minus the first one, which is 0, over my second x, x2, minus x1. Okay, so the result is 4. Okay, now you can compare these two slopes. The blue one, the slope is 4. You see that it's steeper, bigger value, right? And the red line, the slope is 1, so it's less steep than the blue one. Let's look at another example. Okay, so I have again two lines, but this time looks like these two lines, they have the same steepness. Let's figure out what they are first of all. So let's call the green one slope M3. Okay, I can pick any point. Let me pick this point right here. I'm going to pick negative 3, 2. Okay, which is this point right here. And then of course I like to pick 0, 0. Okay, so the slope is, where should I go? Do I go from negative 3, 2 to 0, 0, or do I go from 0, 0 to negative 3, 2? Or does it matter? Okay, so let me try going from negative 3, 2 to 0, 0. Okay, so going from there, I have 2, which is the y, I'm looking for y change, minus 0 over negative 3 minus 0, and I get negative 2 over 3. And you should not be surprised that I get a negative number, because we saw before that in this example, as x increases, like going from the left to right, x increases going from left to right, but y actually goes down from higher points to a lower point, right? So one decreases, the other increases. So one number is negative, one number is positive. Okay, and in this example, I was like treating this origin as where I began and I ended at this point. What if I do the reverse? What if I start from this point here and then I end up here? Would that change the slope? Let's give it a try, okay? So consider this. So this time I'm going to take 0 minus 2, the y change, and then x change is 0 minus negative 3. Let's see what that is. That is negative 2 over 3 again. Oh, so do you see that actually it doesn't really matter, you know, which one I start with to subtract, as long as I always start with that point. Okay, if I start with the y of this point, then in the bottom I will also start with this x to subtract the other one. But the result is going to be the same. Doesn't matter which one I use to subtract which one. Very interesting. All right, let's look at the other one. M4 for this purple line. So I'm going to pick, I don't have 0, 0 to pick, but that's okay. So I can pick this point, 3 and negative 1, okay? And then this one looks quite good. So I'm going to pick this point right here, which is 0 in the x and 1 in the y. Okay, so let me pick these 2 points. Again, doesn't matter which one I start to use to subtract which other one, because we just saw that it's the same. So let me start with the point that is this one, 0, 1, to do the subtraction. So 1, which is the y, subtract the other y, okay, over 0, subtract 3. What do I have here? The top is 2, the bottom is negative 3. So again, I have negative 2 over 3. Do you notice that these two lines, they have the same slope, negative 2 over 3? But obviously, you can tell that these two lines are different because one passes through the origin, the other one doesn't. And it really doesn't matter because the slope measures the steepness of the line, not like which points exactly that it has to pass through. However, these two lines are different, as you can tell, right? Because this one passes through the origin. Remember from what we learned previously in the previous video, this line actually represents a proportional relationship, because proportional relationship is a line, like a straight line, that passes through the origin. And for this one, Well, even though it has the same slope, the same slope m4 compared to m3, same steepness. This line, however, does not pass through the origin. So this line, what do you think? Is it proportional relationship or not? That's right, it's not a proportional relationship. Finally, here's the summary for today's lesson. For a line, the slope m is also its rate of change between any 2 points. I want to emphasize any 2 points. It doesn't really matter which 2 points you choose because it's always constant. And that is defined as y2 minus y1 over x2 minus x1, like the change in y over the change in x, the vertical change over horizontal change, the change in dependent variable over the change in independent variable. And then we also saw that the greater the slope, the steeper the line, the value. Okay, the m value is great, then the line is steep. Also, the slope of a line leaning left, like in this these two examples, like leaning left, going that way. Okay, the slope is negative. Thank you for watching.